Welcome. This is our video that follows the introduction to the circle and its properties. So we are beginning with the length of an arc. If I draw a circle, a small one, then I've put there an arc, maybe AB. Allow me call the center O, and the angle it is subtending. Allow me still use the Greek letter theta. That is theta. Such that, so how do I remember that the length of the whole circle is what we call the circumference, meaning the length of the minor arc AB, the length of the minor arc AB. So how will I calculate the length of the minor arc AB? So remember that the circumference is given by 2 pi r, but then what I want is simply a small portion of the circumference. So I get the angle that portion is making divided by the total tan, angles at a point at 360 degrees, then multiplied by the circumference, multiplied by the circumference. In other words, it is theta out of 360 multiplied by 2 pi r, multiplied by 2 pi r. Yeah, so let us make it better and then talk about also the area of an arc, but it follows the same algorithm. Area of an arc, that you know that the area of a circle is given by pi r squared, or simply pi d squared out of 4. So the area of this now, so area that an arc makes is what we call this region here, we call it a sector. This region is a sector. Area of an arc that an arc is making is area of a sector. So area of the sector, area of a sector OBA. Area of a sector OBA, still the same thing. So this will equal to the angle theta out of 360 multiplied by the area of the circle, which is pi r squared. I can just simply dot pi r squared. As interesting as that. So let's get a calculation and see how we can calculate the length of an arc and area of a sector. So now we are going into the questions on the circle properties, because in the first videos we are only explaining some key terms that we're going to use. So we have a circle of radius 7 centimeters, then we calculate the length of the chord, which is 3 centimeters from the center as a solution part. If we try to sketch what they are talking about, I have here a center, I can have here a chord, but then they are saying that this chord is at a distance of 3 centimeters. The circle has a radius of 7. So how can I use my radius to help me in this calculation? Allow me get the radius, join it to one side of the chord, and join it on another side of the chord. Then I can say this guy is at 90 degrees, such that the radius is going to be 7 centimeters equal, this is 7 centimeters. So that if I call this O, this B, this C, this A, that one A. So if I use if I extract out triangle, let me try to see whether economics will work. If I extract out a small triangle from that body, OCA, which is a right angle triangle, OCA, such that OCA, this is 7 centimeters, this is 3 centimeters. To get CA, which is a half, because this distance and this one are equal, it is half, such that my CA from Pythagoras, I square this one plus this one squared is equal to the other one squared, meaning that CA squared plus 3 squared is equal to 7 squared. In other words, my CA squared plus 9 will equal to 49. But then you take the 9 the other side minus 9, my CA is equal to the square root of 40, but this one is in centimeters, such that if I want BA, it is twice that guy, meaning my BA is simply twice the square root of 40 in centimeters. If you want to simplify the 40, it is the same as 4 times 10, then root on each, then we get a 2, root 10 times 2, we go to a 4 root of 10 in centimeters as the third reduction. In case you don't understand such a reduction, I would request you to go and review our work on thirds. We have more detailed examples on such simple reductions. Otherwise, let's go forward. Our next question. Yes, so we have our next question, that in a circle of radius 5 centimeters, you calculate the length of the chord, which is 3 centimeters from the center. And that one is a trial question for the student. Yeah, so we can go to tangents to circles, tangents to circles, tangents to a circle. So students, a tangent to a circle makes an angle of 90 degrees with the radius. That one we should know, that whenever I have a tangent meeting a circle, it makes an angle of 90 degrees with the radius, if this guy is a t. So if I have a tangent is a line touching just a single point on a circle, so any tangent touching a circle meets the radius at 90 degrees. Let us have a question. Okay, so we have our question that TA is a tangent to a circle of center O and radius 7 centimeters. OT is 12 centimeters. Then the diagram is there. Our part of the question, they are saying that calculate part A, length AT. So if I'm to calculate the length AT, I already know that the tangent meets the radius at 90 degrees, meaning if I have this guy as 12 centimeters, this one as 6 centimeters, I go and apply Pythagoras theorem that 8 squared plus 6 squared is equal to 12 squared, so that I have 80 squared plus 36 will equal to 12, which is 144. Take it to the other side, 80 squared will equal to 108. Take the square root, 80 squared is equal to the square root of 108. Because it has no perfect square root, you can leave it like that, or you can choose to round it off to 2 decimal places as 10.39 centimeters as my simply AT, such that the square and the square root sign disappear. So my AT is 10.39 centimeters. Part B is the angle AOT. The angle, allow me bisect here such that you see what I'm talking about. So part B is the angle AOT. The angle AOT is this angle, and if I call it angle alpha, you are going to, if I extract out, take a very small triangle, such that if this is O, this will be my alpha, and then this is, I think, A, this one is T. This guy, the longest side is 12 centimeters, this one is 6 centimeters, and then this one is 10.39, such that I can use now any trig function to create a relation. So if I use tan from SOHCAHTOA, tan is opposite out of adjacent, it means my tan alpha is equal to the opposite side, 10.39, divided by the adjacent side is the side where the angle is lying, which is a 6, such that my alpha is equal to the tan arc of 10.39 out of 6, which is approximately 60 degrees as my value of angle alpha. So our part C is the area of the shaded part. To get the area of the shaded part, we first get the area of the whole triangle, AOT, AOT, area of the whole triangle, AOT, which is a half base height, whereby you have this as a half times our base. If you allow me go back, our base was 6 centimeters and our height is 10.39. So this is times 6 multiplied by 6 multiplied by 10.39.